So I was told by a friend of mine that I should provide some context why I'm here today talking about regenerative agriculture, and it had me stumped. But then I thought about that quick intro, and I should preface it by saying that I did travel a bit, and I did spend that time travelling looking at agricultural systems, and I kept waiting to be stumped by the next systems. I'd be changing climates. I'd be going from a temperate system to a tropical system to an arid system, and each one of those is growing something different. And the thing that got me was just that they were all leaning into the same concepts. They were all leaning into the same ecologies. The farmers all had this wonderful insight as to how the landscapes worked, and as a consequence, none of it seemed to be too complicated. It all seemed to make an awful lot of sense. They were following these rhythms, and it was a wonderful thing for me because I don't have a brain for detail. I can't remember it. So it was a much easier way for me to enter an industry because it made a lot more sense and my brain was able to fathom it. So I guess that's the approach I'm taking in today's discussion. What is regenerative agriculture? I should also mention that I guess my perception of this is probably contrary to a whole bunch of people's. There's a million and one ways that you can interpret this question. And it's also, I guess I've been guided by all the conversations that I've had with some great farmers across SA and Australia, and also some really wonderful scientists, so some of whom are in the room today, but also some that have been in visiting our region. So Dr. Walter Jehne is a particular mention there. But then there's also the likes of Dr. Christine Jones, Nicole Masters and Sandra Postel. So these are the kind of names that I guess I've been looking to in the literature and that type of thing. I'm going to have a quick drink. So, regenerative agriculture. Regenerative agriculture, to me, from what I've interpreted, is simply a system that is leaning into ecology. So it's looking at ecology, it's looking at the landscape-based systems around it, and it's doing its best to mimic it. So we're looking at our natural resource base, whether that's your soil resource, your water resource, your air resource, which is one that we often underestimate, and our biodiversity. We want to see all those things growing in their capacity, growing in their health, growing in their function. Function's a word that's been mentioned an awful lot today, and you'll hear it a few more times. But at the same time, obviously, we need to manage our farming business. There needs to be an economic return. So what is the overlap between agriculture and ecology? What does that look like? How many times, or where do we start with this overlapping space? Can we change our system through a whole range of micro nicks to the point where we start to change the whole system's trajectory to one that is a positive feedback loop? And that positive feedback loop, which I'll get into in a little bit, to me is what regenerative agriculture is. It's aiming for a system that is self-healing. One more thing on this slide. So the other thing is resilience. So why are we talking about regenerative agriculture so much today? And again, we're staring down the barrel of so many abiotic stresses. So we keep hearing more frequent droughts, droughts for longer, out-of-season rainfall, high-intensity rainfall, unpredictable frost windows, all of these things, and they're making farming very difficult. They're making predicting things very, very difficult. Regenerative agriculture aims to create some resilience within the landscape that you're farming on. So if you can have that resilience within your actual landscape, then you've got somewhat of a buffer. And this doesn't mean it's the solution, and we've got so many forms of agriculture that we need to look at all of them and combine them all in a sensible way to have as many tools in our belt as we start to look at this. This future that is going to be a little bit more unpredictable and make things a little bit more difficult. So that takes me to soil. I've got a background in soil, so I'm a little bit biased, but I think we can start by looking at soils and the fact, or actually, I'll go back. I'm going to now talk about the function. The function of soils, the function of your system. But I forgot to mention, while I do this, I think as a group, as a collective, if we can imagine the function that I'm talking about, but you individually, if you can imagine your systems. So the logistics for you every day, the business rationale for you every day, because it's those overlaps of your logistics, your business, your rationales, all of those things overlaid over these systems, over this function, and that's where the opportunities are going to be, because they're all going to be according to place, according to your landscape. So soil. Soil is basically the driving ecological function on Earth. It's everything. I'm biased, but it is very much true. It drives all of living terrestrial systems. It drives our hydrological system. Without soil, or as soil declines, or if it inclines, it's affecting our climates, temperatures. So these are all really, really big things, and we just can't overestimate the value of soil. It is everything, so we need to treasure it. But where are we today? Let's look at it from the other perspective. 40% of the soils on Earth are now aridified due to human-induced land management. So aridification, what does this really mean? It means that we're losing the function of our soils. Our soils' ecological capacity is decreasing. Again, going back to that discussion around what does that mean for our water cycles? What does that mean for our ecology? What does that mean for our farming? Certainly not going to make farming easier. So this is all sounding very big. It all sounds all-encompassing. But I listen to Walter Jehne a lot, and he sees this as a point of agency, as he would say it. It is a land management opportunity. There is few opportunities that we have to be able to change what we've got on our local scale and consequently change how things work on a global scale. And managing soil is one of the few. And it goes back to the function of that soil. So we need to look at the function of the soil. We need to repair the function of the soil. We need to take the benefits of what that's going to provide us on our local scale and our business scale. And in combination, we're going to see the benefits of that globally. And here we are suddenly at this point that sounds so depressing, and then it's so empowering. There's all this opportunity. So when I say there's all this opportunity, I guess that is a great segue as to why. One more drink. So these are all going to be really pretty basic concepts. Like I said, I'm a systems thinker, and I've been listening to people who are systems thinkers, so it's pretty much just going over a lot of what's already been said as well, so apologies for that. But just going to tell a story, and it's the story of regenerating your soil. But it's going to encompass plants, it's going to encompass the hydrological cycle, it's going to talk about biodiversity, and it's going to talk about soil and soil carbon. And that's because these things are indistinguishable. They've been evolving together for billions of years. We can't silo them. They all interact. There's no one starts here and the other stops. It is just one system. And hopefully that point will come across as we go through this next section. But let's start with plants. So plants are taking carbon dioxide from the atmosphere. They're taking the sunlight energy, a whole bunch of other gases, all of which are free. And they're taking them down into the plant itself, and they're going to push it out into the roots. And they're going to do this a number of ways, but through root exudates is one of the more recent and interesting discussions. And we can go into that. We can talk about what root exudates are doing on a biological level, and that goes into the biodiversity discussion. So these root exudates, each plant is providing specific ones to specific communities. Those specific communities are serving a specific function to that plant. So those particular microbes might be mineralising, they might be bartering with another group, they might just be eating and producing and being a part of that ecosystem, forming some of the stable soil carbons that Amanda was talking about previously. But that's a whole other discussion, and it's massive. And it goes into this whole discussion of microbiome, and it's too big for me. But what we just need to know is that it is occurring, that a living plant in the soil is providing constant nourishment to the soil. And you can take that concept and then you can amplify it. So then you can say, okay, well, if one plant's going to do that, what if we add in a diversity of plants? So then you start talking about what happens when you add in a whole range of different plants into one system. And this system starts to amplify. And you get the same processes, but you get more bugs in the soil. Each of those bugs performing its separate job, mineralisation, cycling, all these processes are starting to happen really quickly. And it's this really simple process of just a living plant. You know, it does it. The soil's going to try to have that living plant there, whether you like it or not. It's what it wants to do because that's what it's evolved to do. So then there's obviously the other form or other half of this cycle where we've actually got the cycling of the dead materials themselves, and that starts to go through a similar process of we've been discussing. So it's feeding insects, feeding microbes. It's going to go through the whole food soil web, and eventually you're going to end up with a smaller, much smaller version of these stable soil carbons. So we got, as has been mentioned, more than one carbon cycle within the soil. But let's look at why this carbon cycle is so important. And this is the bit where regenerative agriculture starts to really hone in. So it's not so much about practices, just keep that in mind. It's about where you're getting to. And a lot of this latest science about how soil functions, the biodiversity, the carbon cycles, all this kind of stuff is what it is essentially looking at. So soil carbon, what's it doing? Why are we so obsessed with it? On a physical level, on what we're seeing, what happens when we put a shovel into the ground. Stable soil carbon, as it starts to accumulate within the soil, it pushes outwards. So think of a sponge. You're getting that spongy layer. On a physical sense again, what does that spongy layer do? Well, straight up, it creates airspace. Airspace is creating the opportunity for plants and microbes to breathe. And this is where you can start to really kick in this discussion around a positive feedback loop. Because as your plants and microbes are able to breathe, I don't know about you, I really like breathing. I'm learning that even more at the moment because the baby's not letting me do it very well. But if you're able to breathe, you're able to thrive. You're able to reproduce, you're able to have a feed, you're able to make more friends. Breathing's very important. The more plants are able to breathe, the more plants are able to live in a certain environment. The more plants are able to live in that environment, the more microbes that they're going to sustain, the more soil carbon you're going to accumulate. The positive feedback loop starts. And then we can start to look at things like, well, all right, we're accumulating more soil carbon. It's creating more space. What else is it doing? This is basic soil structure. It's allowing the water to actually enter the soil in the first place. Water equals life. Water's a real big one. I'll probably touch on the water cycle. So we all know about the water cycle. Whoop, I always forget to change the slides. Here we go. We all know about the water cycle. It's one of the first things that we learn about when we're at school. But essentially, rain falls on the land, finds its way to estuaries. Estuaries find its way to rivers and streams and oceans and evaporation, clouds. Cycle begins again, loosely speaking. But this is the large water cycle. There's another water cycle that's very important. And this is the water cycle that is very empowering, because it is estimated that 50% of the rainfall or the water cycles within Australia come from the small water cycle. And this is the one that you guys control. So the small water cycle is what actually happens to that drop of water when it lands on our soil. At the moment, about 50% of that water that's dropping on the soil is evaporating. So it's not entering the soil and it's not entering that water cycle. It's going back up as water vapour, which, as a side note, has a warming effect. And we're probably not looking for warming effects at this stage, much like carbon dioxide, except much worse. So we actually want to see that water enter our soil. The capacity for water within the soil globally, I think it holds like 8 times more water than all the rivers and lakes and freshwater bodies. It's something massive. Not a numbers person, so don't quote me on that one. But it's huge. So the soil water reservoir is a massive one. But it has to be able to enter there in the first place. And at the moment, things like compaction, non-wetting, low soil carbon are preventing it from entering. So here we are. We're increasing our soil carbon, we're increasing our soil structure. The water is entering the soil in the first place. And on top of that, the water is able to bond in the Goldilocks way with the carbon within the soil and stay there for longer. And with the water within our soil, it's staying there for longer. It's more available to more plants, more available to more microbes. More water, more plants, more microbes, more soil carbon. To quote Walter Jehne, about 1 gram of soil carbon accumulated in your soil, you're going to see about 7 to 8 grams of water storage capacity. So suddenly we're increasing the capacity for our soils to have more water yet again. And this positive feedback loop continues. So I think that's probably enough of this feedback loop discussion. I don't need to get into detail, and you can go as deep and as high as you want to look at this. There's so many angles to it, and there's so many incredible academics that are investigating all the different ways that you can interpret this. It's pretty fascinating stuff. But for the most part, I guess it's the concept, it's the trajectory. So that kind of takes me to where we are now. So you've probably noticed today that I'm talking about regenerative agriculture, but I've not actually spoken about agriculture so much itself, and that is intentional. I don't think I'm the person that should speak in depth about someone else's farming system, because they're the ones that know why they made the decision to make that first tweak to their system. They're the ones that know what caused them to make that big change. They're the ones to tell that story, not me, and I can provide you so many resources of people telling it and telling it really well. But I guess what I'm here today is to say that this is also your story. You're the ones that are watching your landscape. You're the ones that are witnessing how this works. So you'll know how to tap into this type of positive feedback loop. How it's been interpreted, a lot of the stuff that we see, a lot of the examples that we can see, they're quite natural when you actually look at, I guess, the system that they're trying to tap into. So things like multi-species cover cropping. I mean, that makes a lot of sense when you look at this conversation. It's more plants, more longevity of those plants, and a more diversity of those plants. Then there's things like holistic grazing. Again, we're looking at increasing the vegetative state of a grassland so that it's growing, producing sugars into the soil for a longer period of time. But what these concepts don't do is apply them to your logistics. And what these concepts don't do is allow us to see how the order of this landscape is going to actually run before we start to see change. So we've got things like non-wetting soils, and subsoil acidity, and I mean, South Australia, we've got a lot. We're dealing with a lot. So we don't really know the timeframes around turning anything around or increasing a trajectory rate. We don't really know too much about that. We're all looking at it now. We're all trying to figure it out. But what we do know is that we can look at things like non-wetting, and we know that a part of the issue with something like that is the soil trying to protect itself when it's really hot and dry. So we can have a systems thinking approach and start to look at some of these things and think, okay, what's the starting point? And how do I need to line these up? Do I need to line that one up first? Or do I need to look at the system and it'll line itself up separately? I don't know. But it's a fascinating discussion to have and a worthy discussion to have, which brings me to the next point, which is I'm a part of a project. It's called the Regenerative Opportunities in a Low Rainfall Zone project. It's Birchip Cropping Group, Mallee Sustainable Farming, CSIRO, ourselves, and the Mallee Catchment CMA. And as a part of this project, we've started a literature review. So first thing, if you have any literature that you think is important for this, please send it through to me and I'll make sure it's included, or I'll send it to Birchip Cropping Group. They're the ones that are really pulling it together. But secondly, as a part of this, we want to be able to gather your ideas around what these systems are. What are you doing currently that is regenerative? What do you see the opportunities are? What are the gaps? Where are we at? So we're going to have a facilitated conversation on the week of the 25th of March. I'm still finalising that, but you're so welcome to come and contribute in any way. It could just be that the logistics of this system just don't make sense to you, and that's fine. Or it could be that you're an expert in precision agriculture, and there's an awful lot of precision agriculture incorporated in with these regenerative techniques. It doesn't have to be a one versus the other. There is so much overlap, and we're at a point in time where we can design this system to this space. It doesn't have to be a one-fits-all type of thing that we're looking at. And finally, shameless plug, but we are also having a carbon accounting workshop. So it does also follow on. So if you want to know where you're sitting, how your business is actually tracking, that's another option that we're going to be hosting on the 29th. So feel free to see me on that. Just one final thing. I'm not as antisocial as I look. I'm being really careful with the COVID stuff and being pregnant, but feel free to email and call me. It's so antisocial. And I've got also just, a lot of information, a lot of links, and I'm also involved in another project, Regenerative Grazing in SA. As Amanda mentioned, we've got 5 years' worth of data, and we're at the point now where that's starting to come together, and we actually will be having case studies and information. So I'm pretty eager to get that out as well. So that is also imminent. And that is me done. Yeah, thank you.